Alright friends, welcome back. In this video we're going to go ahead and start section 7.2. We'll take a day one for this, and in this video we want to go ahead and talk about how we can perform a couple of simple operations with matrices. And so if you didn't catch the 7.1 video where we talked about what a matrix is, you may want to go ahead and catch that one before you continue to watch this one. But let's go ahead and start ourselves off here by talking about what it takes for matrices to be equal to each other. Really simple and straightforward. Basically, there's only two criteria for matrices to be equal to each other. So first of all, they have to have the same order, right? So we talked about what order was in the last video. So the same number of rows and the same number of columns in both of your matrices if you're trying to say that they're equal. And then secondly, they have to have corresponding entries that are equal, okay? And so in the case of this first example right here where we have these two different 2x2 matrices, you notice the corresponding entries are going to match here, right? So I have 2 matching 2, that was entry A11. I have the next entry here, -1 and -1. That is simple and straightforward here. And even though these next ones look a little bit different, they are equal to each other, right? So this is the square root of 4, and we have 2 here. Well, we know that the square root of 4 is equal to 2, and so that counts here for us. And so in the next one here as well, that's going to be the same thing, right? I have an entry here of 1/2, and I know that as a decimal that is simply equal to 0.5. And so we have a 2x2 equals a 2x2. And because each corresponding entry matches up and is equal to each other, we would say that these two matrices are equal matrices. But here's an example where I have two matrices that are not equal, right? So you might notice here that they have some entries in common, but the problem here is that this is a 2x3 matrix, and this is a 2x2 matrix. And we said before that in order for matrices to be equal, they do have to have the same order. And so because these have different order, they are not equal matrices. And so really easy criteria to have to look out for. And that's going to go ahead and help us as we move on to the next thing to do with matrices, which is, of course, to add or subtract them. This is a classic type of ACT question, right? So maybe even you've seen these on the ACT and were able to get these correct because they are kind of pretty straightforward, right? They work in the way that you think that they might. But let's go through it here, right? So it says to add and subtract two matrices, all we have to do is add or subtract the numbers that are in corresponding entries here. And so you can see the diagram here. I'm going to add two different 2x2 matrices, and you can see how that works. I'm basically just taking the 3 and the 4 because they are in corresponding entries. I'm adding them together, and that creates the corresponding entry for my answer. Okay, so 3 plus 4 makes 7, and then that's the same thing going along everything else, right? So 8 plus 0 is going to make 8. Okay, and et cetera, et cetera, et cetera. You can see how this works. Really straightforward. The only thing to point out here is this right here. It says 2 or more matrices must have the same order in order for us to add or subtract them. Again, the reason for that is because we have to have matching entries, corresponding entries to add or subtract together. Okay, and if they're different orders, then we're not going to have certain entries to match up to certain other ones, and so we wouldn't be able to make sense out of how to add or subtract those entire matrices together. So let's take a look at a couple of examples here. Again, these are really straightforward, so we're going to go ahead and blaze through these here. But we're adding two different 2x2 matrices here, and of course we're just going to go ahead and simply add the entries, right? So -1 plus 1, we know that that is going to make 0. We have here 2 plus 3, that of course is going to make 5. We have 0 plus -1. So 0 plus -1, remember that we're adding here, that's going to give us -1. And then finally we've got 1 plus 2, of course that's going to make 3. I am not trying to trick you, it really is that simple. Please go ahead and make sure that you include those square brackets. It's the kind of universal symbol there that tells us that we're working with a matrix here. You can see other types of grouping symbols like parentheses or even curly braces in some cases, but here we're going to go ahead and stick strictly with the square brackets here. Okay. In the next one down, we have this 3x3 matrix that we're trying to add to a 3x2 matrix, and we are not actually going to be able to do this, right? Because remember that we need to have matching orders in order for us to go ahead and add these two together, okay? And these have different orders. One's a 3x3, the other's a 3x2, and so we would not be able to go ahead and add these together, so the conclusion there would simply be that the sum of these two matrices is going to be undefined, okay? Moving on to the next one, we have, just checking the orders here, we have a 3x1, 3 rows, 1 column. That we are subtracting off another 3x1, again 3 rows, 1 column, and so because they have matching orders, we have the green light to go ahead and subtract these up. And again, this works in the exact same way that you might think, right? So 1 minus -1, just watching the signs there, minus off a negative, that changes to plus, so that's going to be a +2. The next entries down, we've got here -3 minus 3, that's going to give you -6. And then finally, we've got negative 2 minus 2. That's going to give you negative 4 here, okay? And so once we lump that off with a set of square brackets, we are going to go ahead and call that one done. So very, very simple to do. Again, the most important tip that I have for you is just to make sure that you are checking the orders first before you're continuing and starting to add corresponding entries together. They have to match in order for us to add and subtract matrices. And so one of the other things that we can do is we can go ahead and multiply a matrix times a number and then start to do some combinations of various operations here, right? So when you multiply a matrix times a number like we are going to do here in part 1 of what we're doing, it says for the following matrices, we need to first of all find 3 times A. All we're going to do is we're going to multiply 3 times each entry of the matrix A, okay? And so in part 1, if we're going to go ahead and write that out, 3 times A, you can see that the entries for A are listed up above. We're just going to go ahead and multiply each one of those by 6. So starting us off here, we have 3 times 2, of course that makes 6. We have 3 times 2 again, that's going to make 6 again. We have 3 times 4, that's going to make 12. We have 3 times negative 3, that's going to give you negative 9. We have 3 times 0, of course that's going to make 0, and all the way through. You guys can see how this works, right? So I'm just going to go ahead and finish this one off here, and then we'll go through and take a look at some of these other ones, right? So 3 times 2 is 6, 3 times 1 is 3, and then 3 times 1 is 3 again, okay? So really, really simple to do. Whenever you're multiplying a matrix times a value, we call that a scalar multiple, which you may want to go ahead and write down because that's not the last time we'll use that terminology here. That just means we need to go ahead and multiply each entry of a matrix times a certain scalar or a certain number, okay? So scalar multiplication, very, very important to know how to do. The next one down, we need to go ahead and perform this next operation, which is to go ahead and take negative b, okay? So another way that you can interpret that would be to go ahead and say, we are just going to interpret that as negative 1 times all of the entries of the matrix B. And so basically, we're just going to change the sign of all of those entries here in matrix B here. So we'll go ahead and do that quickly, right? So remember that if it's ever 0, 0 is not a number that's considered to have a sign, so we're going to leave that as 0. But we're going to change the sign of everything else, right? So that'll be negative 2, negative 1, positive 1. That'll be 0, positive 4, negative 3, and then 0, negative 3, negative 2. Again, not trying to trick you. Really is that simple, okay? When you start off talking about matrices, usually things are nice and straightforward for you, okay? And so now what we want to do is we want to go ahead and do this last part here, right, which is to perform these operations here. So not only do we need to take 3 times A, but we need to subtract off B, okay? Another way that you could interpret that would be to use the following two, or not the following, but the preceding two results, right? We already figured out what 3A is, and we already figured out what negative B is. So if we need to figure out what 3A minus B is, another way that you could interpret that would be to say 3A plus negative B, because remember, whenever you add on a negative number, that changes to minus, just like we have here. So because we already figured those two matrices out in the previous ones, we could just go ahead and simply just add them together, which again means that we're adding corresponding entries, and then we're going to be finished up here. So I'm going to keep those in view while I go ahead and work this out here. So that's going to be 3A minus B. Again, all I'm going to do is I'm going to add the corresponding entries in the previous two matrices, and we're going to be good to go. First thing I do need to check, though, is that this is a 3 by 3, and this also is a 3 by 3. Again, we wouldn't be able to add them together if they didn't have the same order, so that's always the first thing you need to check for, but we have the green light here, right? So we're just going to go ahead and add corresponding entries together. So that's going to be a 6 plus negative 2. That's going to give you positive 4. 6 plus 0 is going to give you 6. We have 12 plus 0. That's going to give you 12. We have negative 9 plus negative 1. That's going to give you negative 10. We have 0 plus 4. That's going to make 0. Or not 0, goodness, I meant 4. Next one up, we have negative 3 plus negative 3. That's going to give you negative 6. Next up, we have 6 plus 1. That's going to give you 7. And then 3 plus negative 3 is 0. And 3 plus negative 2 is 1. Okay, so just adding up all the corresponding entries of the previous two matrices, this will allow us to go ahead and figure out the result of this, 3A minus B. Again, you might have some other examples where you might need to go ahead and figure out a different scalar multiple of a matrix first before you add or subtract onto another matrix there. So I would just encourage you to really read the directions carefully and make sure that you're doing all the operations that you're supposed to be doing for figuring these out. But that's actually all I have for this video. So just doing some very simple operations with matrices, very, very simple to do. As always, if you guys have any questions whatsoever, feel free to let me know. But thank you very much for your attention, and I'll speak to you in the next one.